in this session, let us see most important area, because from this area only question can come in parallel operation of transformers. Like, as I told in my previous session, 5 conditions will be there. In that, most probably question can come only from this area. Okay. Before starting this, I would like to tell few things. Okay. Basically, organizations. Okay. Organizations, rather than focusing on money, focus on quality. Okay, and faculties also, it's a sincere suggestion. Okay, and maybe a sweet warning also. Okay, basically whenever I used to take offline classes, means clearly I used to tell to my students, this is misconcept which is being published or something. Okay, so actually some organizations are promoting misconceptions, conceptual errors. Okay, basically it's a social crime. Okay, because student is a small kid. Whatever we feed, he feel that guru is always right. Okay, and he feel guru is right. Okay, and if we promote conceptual mistakes, it's a social crime. Okay, in this also just by taking concept without going through the basics. Okay, so some publications has published completely wrong, and most of the students are feeling that published thing is right. Okay, one thing here to after taking huge amount, and student, he does not know anything, student will pay that huge money, and student will give 10 feedback also to the faculty. But if the same question come in exam, if student lose 1 or 2 marks, because of that, he may lose public sector job, or he may lose IIT. Okay, so my sincere suggestion is, don't promote misconceptions. Okay, so let us give quality. Okay, means I'm calling all the online or offline guys. Okay, so let us give quality. If you are unable to understand a concept, we have time now. Being faculties, we have time. Okay, and being content team, you have time. Okay, and being organizations, this is the organization responsibility to publish the things properly. Okay, otherwise, for example, whoever attended classes and all, maybe I used to tell. Okay, but many guys might have bought their publications from different locations in India, and they feel that it is right. Okay, so regularly guys has to update the quality. Otherwise, these misconceptions, even in fault analysis also, that particular misconceptions promoted, and now people are feeling those misconceptions are right. Okay, so in this also, let us see what is that misconception. Okay, and we should not do that. Okay, so for example, in this parallel operation, in this condition, okay, so in this condition, if turns ratios are same in single phase transformer, if turns ratios are same, okay, so when turns ratios are same, for example, if I think of this primary and this primary, both are connected to the same wires, and this is secondary connected to the same wires. Okay, so then what will happen? For example, if I supply some voltage here, if I supply same voltage here, if turns ratios are same, induced voltage here and induced voltage here will be same. Okay, means that my model will be RE2, XE2 will be there here. Okay, so my model will be RE2, XE2 and internal impedance, voltage, RE2 and XE2 and internal impedance. Okay, so this is ZE2 of transformer A, this is ZE2 of transformer B. And when turns ratios are same, induced voltages are same. So for example, if this is induced voltage E2 of transformer A, this will be E2 of transformer B, both are same. So the moment both are same, I can connect these two. Okay, and I can remove one. Okay, such that one voltage source will be there in the model and 2 will be there in the parallel path. Okay, so the logic here is damn simple. Think of network theory. Don't don't go to oversimplifiedness. Okay, stick to the basics. Let us observe. For example, if some current which is IL, Okay, so this current is IA, this current is IB. Okay, so how much is IA? IA equal to total current IL into other impedance ZB divided by total impedance ZA plus ZB. Okay, so in this equation, if load current is lagging, will you place minus or plus? Minus. So this will become minus automatically. For example, if IL is leading, it will become plus. Now in that, let me add VT here. Okay, so VT into IA is going to be SA equal to, in the sense, load shared by transformer A. Load shared by transformer A, SA, is going to be VT into IL, total load, into ZB by ZA plus ZB. Okay, so in this also, if IL is lagging, you have to use minus. If SL is lagging, you have to use minus only. Okay, for example, if SL, total output across VT, terminal voltage, and IL is at 0.8 power factor lag, you have to use minus 36.87. So SL at an angle minus 36.87. Now, misconcept came like this. Okay, for example, what is S? Equal to VI complex conjugate, no? So this is yes, no? So the moment it is yes, I complex conjugate. Okay, I complex conjugate in the sense, if I is lagging, we have to use plus. But this is altogether different. Okay, for example, why complex conjugate has to be analyzed. Okay, so for example, if I have voltage like this V, if I have current like this I, okay, so what is active power? Forget about reactive power, we'll see later. What is about active power? VI cos pi. So is going to be VI cos pi. Now V is at an angle 0, I is at an angle, for example, minus 30. Okay, so this is going to be VI cos 30, because minus 30 or plus 30 will be same. Now for example, let me see here. If V is like this, at an angle 45, now I is like this, at an angle 15 degrees. Now if I think of, directly V into I is power, so S equal to V into I, if you consider, that is going to be V at an angle 45 into I at an angle 15 is going to be VI at an angle 60 degrees will come. Okay, so point here is, what is power? Means active power, at least voltage multiplied by current multiplied by cos of the angle between voltage and current. What is the angle here? 45 minus 15 is going to be 30. But how much you are getting here? 60. So it is wrong. Okay, so what, we can do VI complex conjugate or V complex conjugate I. Okay, for example, V at an angle 45. I complex conjugate, if I apply, then automatically the moment it is complex conjugate, in this is minus 15, 45 minus 15 is going to be 30. Correct? Okay, so for that purpose, we use VI complex conjugate, or V complex conjugate I is also same. For example, if I do V complex conjugate I, V at an angle complex conjugate minus 45 into I at an angle 15. So this is going to be VI at an angle minus 30. Okay, so depending upon the need, we can do V complex conjugate I, or depending on the need, I can do V complex conjugate. But these are altogether different. Okay, because basically this formula came from currents. Okay, for example, forget about this. Okay, total current is IL. If you want to have current here, total current into other resistance divided by total resistance is the current division rule of network theory. For that, I am adding VT at an angle 0, VT at an angle 0, you are going to get SASL. Okay, for example, if this particular terminal voltage is at an angle 10, under that condition, V complex conjugate I should be taken. Okay, V complex conjugate I should be taken, but VI complex conjugate should not be taken. So point here is very simple. What is that? Total power, what do you say, power shared by or load shared by transformer A equal to total load and the combination. If it is lagging, you have to take minus only. If it is leading, you have to take plus only. Plus only. Try to maintain quality here, please. Not to students, to others. Okay. So it means at an angle minus. If it is lagging, ZB by ZU. Over. Okay. Now let us solve some old gate problems. See here. And before that, okay, I have to tell one more thing. That is, like, you know, about per units. Okay. For example, see here. If I think of conducting short circuit test. For example, means this is going to be the model for any transformer. Okay. So this is E2, this is I2, this is V2. Such that this is ZE2. Okay. Now on this, if I want to conduct short circuit test. Okay. So if I want to conduct short circuit test, for example, at full load current. How much should be the short circuit voltage to be supplied? Short circuit voltage to be supplied equal to full load current multiplied by ZE2. So IFL multiplied by ZE2. Okay. So short circuit voltage to be supplied to circulate full load currents in this is going to be IFL ZE2. Now, for example, logic is simple. For example, this full load current is 10 amperes and this full load current is 5 amperes. Okay. So for example, now see here. For example, this full load current is 10 amperes. Okay. So this full load current is 5 amperes. Now my impedances should be such a way, because in parallel combination voltage will be same. So whenever it is operating at full load, at the same time if it also operated full load, then 10 plus 5 can be 15 amperes. For example, this is 10 kVA machine. This is 1000 volts. This is 10 kVA machine. 10 amperes multiplied by 1000 volts is going to be 10 kVA. And this is 5 kVA. 1000 into 5 is going to be 5 kVA. Now, means how much amount you invested? Like, you know, for 10 kVA, for example, 10,000 rupees you invested in manufacturing that. For 5 kVA, you have to invest 5,000. Okay. So total amount invested is going to be 15,000 rupees. Now you kept, like, you know, one transformer of 10,000 rupees. You kept transformer of 5,000 rupees. Now in the combination, in order to exploit full of 15,000 rupees, whenever it is supplying 10 kVA, it has to supply 5 kVA. Means that, for example, if full load current of 10 amperes is going through this, okay, at the same time, for the same voltage, full load current of 5 amperes should go. Okay. So how much is the short circuit voltage to be supplied to circulate full load currents for transformer B is going to be 5 into ZB. Should be exactly equal to full load current multiplied by ZA. So 10 amperes multiplied by ZB or 10 kVA multiplied by ZB should be equal to 5 kVA multiplied by ZB. Okay. So 10 kVA multiplied by ZA should be equal to 5 kVA multiplied by ZB, or 10 amperes multiplied by ZA should be equal to 5 amperes multiplied by ZB. Okay. So for example, if you think of Z per unit, okay, so Z per unit normally equal to Z into VA base by V base square. Okay. Of course, in power systems, like, you know, it will become MVA base and it will become KV base square. That's fine. Okay. Now, for example, what is V base? Rated voltage for these two is going to be same or not? Yes. Okay. Now, whenever it is operating at full load, it has to operate at full load such that whenever it is operating at full load 10 kVA, at the same time it will operate at full load 5 kVA. 10 plus 5 will be 15 kVA. Okay. So for example, whenever this is 10 amperes, for example, let me think of this particular ZA value is 0.1 ohm. Think of just like resistance. Okay. So 10 amperes into 0.1 is going to be 1 volt. So whenever 1 volt is happening here, how much current should flow? 5 amperes should go. Means that how much should be the impedance of this? Should be 0.2 ohm. Okay. So 10 amperes into 0.1, 1 volt. So the moment, like, whenever you have the same voltage across this, 5 ampere should go. Means that if this impedance is 0.1, this impedance should be 0.2 ohm. Okay, so now 10 amperes into 0.1 should be equal to 5 amperes into 0.2, or 10 kVA into 0.1 should be equal to 5 kVA into 0.2. Means that, like, for high capacity machine, impedance should be less. For less capacity machine, impedance should be more. So if high capacity machine, impedance should be less. For low capacity machine, impedance should be more, such that Z per unit should be same. Okay, so means my 10 kVA machine should have less impedance, 5 kVA machine should have more impedance, such that Z per unit, if you calculate with respect to 10 kVA for this transformer, Z per unit if you calculate with respect to its own kVA for this transformer, if both are same, what does it mean? For example, if you go back and see per unit quantities of transformers, okay, in that we clearly discussed that. Let me write here. Okay, so VSC at full load equal to ISC into IFL into ZE in ohms. Okay, so the same we analyzed here also. IFL into ZE is nothing but short circuit voltage at full load. Now means if I modify this is going to be VSC, like, for example, for a given transformer, if I say means 0.1% is VSC per unit, per unit. Under that condition, what it will be, like, full load current multiplied by ZE. Okay, so divided by rated voltage is going to be per unit. Okay, so this is going to be VSC full load per unit. Now V base by I base, because IFL is nothing but I base, V base by I base will give you Z base, ZE by Z base will give you ZE per unit. Actually, we solved the problem also and the same in one of the old gate question. But anyway, point here is very simple. How much is the short circuit voltage in per unit? Is nothing but ZE per unit. Okay, so for example, short circuit voltage is IFL ZE of first transformer and second transformer should be same, because whenever it is fully loaded, it also should be fully loaded. Okay, under that condition, short circuit voltage of this and short circuit voltage of this should be same, or ZE per unit with respect to its own kVA ratings should be same. Okay, so point is very simple here. Okay, in order to attain this condition, what is the condition? Means if it is 10 kVA and if it is 5 kVA, total combination should give you 15 kVA. Okay, so in order to attain that, short circuit voltage of this to circulate full load currents, short circuit voltage of this to circulate full load current should be same, or means ZE per unit with respect to its own kVA ratings of 10,000, ZE per unit with respect to its own kVA ratings of 5 kVA should be same. Okay, now logic here is, okay, you have to remember this at any cost, like, because as it is concise course, many things I'm unable to discuss. Okay, but remember one thing. For example, if two transformers are connected in parallel, okay, for example, this ZE is 0.1 per unit, this ZE is 0.1 per unit. Okay, for example, here load current is 15 amperes. Okay, so how much current will flow through this? Is it 10 or is it 7.5? Is it 5? Cannot be decided, but it should be decided by, for example, this is 10 kVA machine, this is 5 kVA machine. Okay, for example, if you don't think of this and if you directly calculate 0.1, if it is 15 amperes, 7.5, 2 equal resistances. No, it is in per unit. Okay, so this 0.1 is with respect to 10 kVA, this 0.1 is with respect to 5 kVA. Under that condition, this 0.1 should be converted into 10 kVA or 10 kVA should be converted into 5 kVA. Okay, so remember one thing. Okay, in calculating load shared, I repeat, in calculating load shared by individual transformers, all per units should be referred to a common base. Okay, common kVA. So for example, if you convert this into 10 kVA, by considering 10 kVA as base for both, under that condition it will become 0.2 per unit. For 5 kVA, 0.1, for 10 kVA, 0.2. So now if you calculate current flowing through this, total current 15 into other impedance, 0.1 divided by total impedance, 0.3. Okay, so point here is very simple, remember this. Okay, means Z per unit should be referred to a common base in parallel operation of transformer while calculating load shared by individual transformers. One thing. And second thing is, you should not do this mistake by following some kind of book. Okay, so actually some people say that if it is lagging you have to keep plus. No, if it is lagging you have to keep minus only, because this is current division rule. Blue is current division rule. Okay, if you remember these two, problems can be solved. Okay, now let us take off two problems now. See, in this problem, two single phase transformers T1 and T2, each rated at 500 kVA, so there is no difference in kVA basis, are operated in parallel. Percentage of impedances of T1 and T2, 1 plus J6, 0.8 plus J0.4, to share a load of 1000 kVA at 0.8 power factor. The contribution of T2. Okay, now actually one thing we have to understand here. The thing is, we are into in the mode of online calc. The moment online calculator, many things they cannot give. Okay, for example, if you try to calculate this way, what will happen? Let us see. For example, S of 2 is going to be total 1000 at an angle minus or plus minus 36.87. Okay, into Z1 is how much? 1 plus J6 divided by Z1 plus Z2. Okay, so total current IL into Z1, because I am calculating S2, Z1 divided by Z1 plus Z2. We should not do that, because this converted into this, complex mode calculation, you will not be able to calculate in time. That's why they asked, what did they ask? kVA only. kVA, T2 kVA is. Okay, so how much is S2 kVA? Is going to be directly take 1000 into 1 plus J6 is going to be under root of 37 divided by under root of 1.8 square plus 10.8 square under root, because he asked only kVA, he did not ask power factor. Okay, so the answer is going to be 550 kVA, I think. Around 550 kVA we are going to get. Okay, so point here is 555 kVA. Okay, so point to be remembered here is very simple. This is recent gate problem. For example, before before online calc, maybe 99 or 2001, they have given one more question. Let us see that. Okay, now TA they have given, TB they have given. To share load of 12 kilowatt at 0.8 power factor lag, determine P and Q, active power and reactive power, by A. The moment active power and reactive power, you have to consider total equation. Now, see here, TA impedance, if you calculate, is going to be 3 plus J4%. Okay, now TB, now TA is 10 kVA, TB is 5 kVA. So, my per unit should be referred to a common base. Common base in the sense, for TB, ZB is going to be, let me consider 10 kVA as the base value. So, 5 kVA, 4 plus J3, it's going to be 8 plus J6. Okay, now we can do S of A. Okay, P and Q delivered by A is going to be, total is on how much? 12 divided by 0.8 at an angle lag minus 36.87. Okay, into what is SA, so ZB, how much is ZB? 8 plus J6 divided by Z1 plus Z2. This question will not come in GATE. Why it will not come? Because complex mode, online calci. So ultimately the answer is going to be, if we see, 0.74 lakh will come. Power factor is going to be 0.74 lakh will come. Our PQ form 7.466 minus J, okay, 6.78. It is in the form of minus Q, in the sense lagging only, because V complex conjugate I we are going to take. Now one thing, like few guys, they don't listen actually. Without knowing the basics, they will fight like VI complex conjugate, because we have seen in power systems multiple times. In power systems I too know that V complex conjugate I also will be taken in some instances. Okay, so for example, let me think of logically. Okay, for example, if I have, of course, whoever properly prepared, they can cross check my comments. Okay, so this is 3 plus J4. Okay, so 3 plus J4 in the sense, what is X by R ratio? 4 by 3 is more than 1. Okay, what is this X by R ratio? 6 by 8. X by R ratio is less than 1. The moment X by R ratio is more, it will become still more lagging. Whenever X by R ratio is less, it will become less lagging compared to the load. Okay, so if load power factor is 0.8 lakh, trust me dear, trust me, I should be right. Now, to share a load of 12 kilowatt at 0.8 power factor lag, wherever X by R ratio is more, transformer should operate at less than this power factor. Wherever X by R ratio is more, less, transformer should work at better power factor than this. Okay, that is the condition, discussion we will see in detailed concept. Now, means in between TA and TB, TA is more, X by R ratio is more, means that it should operate at less power factor than 0.8. So, less power factor only. Okay, so I should be right. Let us see other questions soon.